first thing we were missing in this competition is the fourth member, Christian Lindenberg. He designs and builds our aircraft, and he has to go to hospital. He had to lay flat for the last 3 weeks, so this was very bad for him not to be able to come here and to present his airplane. So that was the first thing missing. This is his aircraft. It's a flat foil aircraft with a 30 centimeter maximum wingspan. It's made of Herrex flat, so we just have a mold which is very flat. There's no foil or whatsoever within it. It's just very, very flat. It still has some uncritical flight behavior, although Jamie would probably say it's not. So it's very good to have the autopilot. And so in some sort, the autopilot is part of the whole system. It's not only fun to fly this small thing, and it's also very difficult to see. You see number one, which does have a Kevlar coverage, and number two and number three don't have that, so they're just glass. That's why we call it the glass one. And so you can actually look through it, and it was very hard to see. And even when we were coming back to the base, you could barely see it, even though it was circling around us. So that's why we call it the glass one. And it's very rough. It just has some carbon around and some Kevlar on the bottom, and we landed very hard, and still it was okay. These are the numbers for it. 30 centimeters is the maximum dimension. The wingspan is 28 centimeters. The airspeed we were flying at yesterday was about 50 meters per second, and we flew for about 20 minutes, though we were not using the 20 minutes. We were coming back before just to make sure we can land. We're using the paparazzi system, or we're part of the paparazzi project, which was started by EMAC, and thankfully it's set open source so that everybody can use it. And they started with that 5 years ago, and we joined about 2005, 2004, end of 2004. And it's very helpful to have that available and to be able to have the system evolve over the time. Someone asked me if it's boring after 5 years of flying the paparazzi, but the system that was existing 5 years ago is not the same as it is today. The mission that we did yesterday would not have been possible with the stuff that we had 5 years ago. You're looking at the ground control station, you see Google Maps, you see all sorts of information, which I will not go in detail to, but all this was not there 5 years ago. So there's a lot of things going on, there's a lot of development, people contributing, people testing. Maybe there'll be some more teams using paparazzi after this competition. From time to time that happens after the competitions. And they all work on it and they all improve it. And we think that's the only way to make an MAV, because you have a lot of fields that you work on. It's not only the aircraft, it's not only the electronics, the software, or just RC flying. It's all together, and that's what we try with the paparazzi system. We have people from all the teams together to do this. So the mission yesterday, this is the setup. We had 3 aircrafts. We had the EOD device, we used the simulated EOD device. We had a telemetry to the EOD device so that we knew where the EOD device was all the time in our system. And we had three planes, 2 of them looking down, 1 of them looking forward, and all was controlled by the ground control station. This is the plan, and the initial idea was to fly over the points and circle and to find the obstacles. We were pretty sure that our system could not see the mines, because as you saw from the MIT pictures, which had a very stable camera, we were just flying over them. So we kind of thought that this would not be possible with a fixed wing aircraft. We had a mission time schedule set up so that we would know about what we would be seeing and what we would be doing to schedule the launch. We launched the first aircraft, and when it was coming back, or it already landed, we launched the second one. We're also looking down camera, and we first tried to find the first. We did the first path on this mission to find obstacles, and then try to get the guard vehicle to get the time schedule on this. And maybe we can take a quick look on the flights that we actually did. This is the first flight. We took off there in the south and flew on the western wing towards the hostage building, and then circled with the aircraft to see the guards on the time schedule. And when it was difficult to see, we increased the circle, so you see that there's a bigger circle. And we also tried different altitudes to fly there. and to see the guard vehicle. And then we launched the second aircraft from there, and we flew on the eastern path towards the building, and we were almost slightly touching the eastern no-fly zone there with the yellow airplane. And then we were flying circles in the middle of the field, because there were a lot of points there to search for obstacles. And then we were coming back, and you see the big circle, and we right then launched the third aircraft while the second aircraft was still in flight, and we separated them a little bit. So you see that the yellow aircraft was flying above the orange aircraft, and one thing was to get the orange aircraft into the air, and the second thing was to see the yellow aircraft. We could hear it perfectly, but couldn't see it. So then we had the orange aircraft, well, it's still the glass one, but the orange color. And with this one, we had the camera which was looking forward. And this gave a much better picture than what we thought what we would get. And we were actually able to fly towards the building. And this is the big path you see there. You're going, it's not really going over the hostage building, but very close, and fly towards the building. And we were lucky that the hostages were in the south building, in the south window, and so we could see the hostages there with the forward-looking camera. The biggest challenge was the size. We had never built an aircraft that small. The smallest we had in the other competitions were like 45 centimeters, and that's the point where you love it very much. So I'd like to thank EMAC for helping us, because without them it would be completely impossible to do that. There was one issue yesterday, the day before yesterday, was the low contrast between the ground and the sky. We have never seen that. We have flown in the deserts of Arizona and the humidity of Florida and 1,000 kilometers away from the North Pole and cold northern Germany, and especially in France, and we never saw such thick and warm dark clouds. So we use infrared to determine the horizon, and if the difference between the sky and the ground is not big enough, we cannot fly. So this kept us from flying 2 days ago. The first day, there was too much wind to do this, and then the other day we couldn't go because of that. And we have never seen that, so that was a new experience. Also, the narrow no-fly zone, we barely touched it, and it was difficult for a fixed-wing aircraft to circle very near the building. It was impossible to circle over the building because that was too small to fly there. So that was a challenge. We would like to thank you for the opportunity to be here, to go to India and fly here, and everybody who was working on this, the whole conference and everything, and especially ENAC. Without them, it wouldn't have been possible. Thanks.
Okay, thanks very much.